So today I want to have a look at solving inequalities, and before I get started, if you have any questions with this video or you've got any other questions about other topics, feel free to comment those down below and I'll be more than happy to answer you. Anyway, let's get started. So you might have seen an inequality that looks something like this. 3x minus 4 is less than 18. Now if this was an equal sign, it would just be an equation, and I'm sure you all could solve that. The way to approach solving an inequality is actually exactly the same, in most cases, as solving an equation. So we're going to do the same thing to both sides until we have x on one side of this inequality sign. So it looks something like this. We're going to add 4 to both sides first. And so on the left, we get rid of the minus 4 and we're left with the 3x. And on the right hand side, we're adding 4 to 18, so that's 22. And then we can divide both sides by 3. And so we're just left with x on the left, and I'm going to leave this as a fraction here on the right. So there we go, x is less than 22 over 13. That is the solution to this inequality. And often an extra step that they'll ask you to take when doing inequality questions is to draw this out on a number line. So let's say we have 8, 9. So this fraction here, 22 over 3, is about 7 and a bit. And we want the section that is x is less than 22 over 3. So 22 over 3 is somewhere there. And the way we represent this, because this is purely less than, x can't actually be equal to 22 over 3, we use a hollow circle above our number, and it is going to the left because x is less than this number here, this 22 over 3. So if this here was a less than or equal to, if it looks something like that, then over here we would represent that using a filled in circle above our number. That's the difference between the two. So let's have a look at another example, a slightly harder one. So here we've got 6 is less than 3x is less than 18. So here we've got an x term sandwiched by two inequality signs. The way to approach this is we split this up into two separate inequalities and we solve those. So our first one would be 6 is less than 3x, and the other one would be 3x is less than 18. Now, you could approach this without separating it and just divide through by 3. That's fine in this case, but sometimes it gets a little bit dodgy and it's just easier if we separate them out now. So we'll divide by 3 on both sides here, so that's 2 is less than x, dividing by 3 there, and let's divide by 3 here as well. So we've got x is less than 6. So now we can combine these two inequalities where we just have x there. So we can put x in the middle in this case, and then we have 2 is less than x, or x is greater than 2, and x is less than 6. So we can also represent this solution on a number line. So in this case, we still have our less than signs without the equals bit at the bottom. So they're going to be hollow circles. And we're going to put 2 above our numbers. And we want the section that is between the two numbers. So I'm just going to connect those like that. Now, if this was slightly different, if x was less than 2 or x was greater than 6, well, again, we'd have our circles above 2 and 6, hollow circles, except this time we want the numbers that are less than 2. So my line is going to be travelling to the left, and we want the numbers that are greater than 6 as well, so I would represent it like that. So let's look at a slightly harder example again. So 5 is less than 3x minus 4, and that in turn is less than 18. So again, we've got an x term sandwiched between two numbers. Let's separate it. So I recommend that you have a go at this question yourself before you watch me walk through it. So there we go. Now I'm going to treat this as an equation. We're going to do the same thing to both sides. So I'm going to add 4 to both sides first. That's going to be 9 is less than 3x. Divide through everything by 3. 9 divided by 3 is 3. And that 3x becomes x. Perfect. On this right hand side, I'm going to do exactly the same thing. We're going to add 4 first. Then divide through by 3. That gets us 22 over 3. So have a go at representing this on a number line. And I'll just show you the solution here. So our first circle is going to be above the number 3. And again, that is a hollow circle because it's just less than, there's no equals bit. And then our second circle is going to be above 22 over 3. And in this case, the x is the part that's greater than 3, so to the right of the number 3, and the part that is less than 22 over 3, so the part to the left, which means it is the middle section there. And I've forgotten to write this as a combined inequality, so let's do that. X here is in the middle, so it would look something like that. So let's have a look at what these inequalities look like on a graph. So let's say we have 3 inequalities. We've got x is greater than 1, y is greater than minus 2, and then we have x plus y is less than 6. So these first two are quite simple to represent on the graph. The line x equals 1 is this line here. So at every single point on this line, I know that the x value is 1. And then this here, this y is greater than minus 2. Well, y equals minus 2. Oops, sorry. Y equals minus 2 is this straight line here. And what about this third one? Well, we can rearrange it so that it's y is less than minus x plus 6. So I've taken x away from both sides there. And so it's going to have a gradient of negative 1, and it's going to intercept at positive 6 on the y-axis. So it's going to look something like this. So I've plotted these as solid lines, but in fact when you're doing an exam paper, you would plot these as dotted lines, because these here, these signs don't include an equals part, so they can't include this line, any of these lines. They can't include any of those lines. So you would draw these as dotted lines, but I obviously can't do that on here. So let's change these to equals, and then my graph is right. So x is greater than or equal to 1. So x can be on this line, but x can't be to the left of this line, because x has got to be greater than 1. So what that means is it's going to be the region that we want is going to be to the right of this x equals 1 line. And then let's have a look at our next one. So y is greater than or equal to minus 2. So y can't be less than minus 2. Our y value can't be less than minus 2. So it's got to be above the line y equals minus 2. So it's got to be to the right of this x equals 1 line. And it has got to be above our y equals minus 2 line. Well, what about this one here, this diagonal? So y is less than or equal to minus x plus 6. So our y value has got to be less than the y values on this line. It can be on this line, but it has to be less than. So the way I think about it is if it's less than, it's going to have to be below the diagonal, and if it's greater than, it's going to have to be above the diagonal. So it's going to be that region there. And combined, these three sort of boundary conditions combined mean that the region enclosed by those three inequalities is going to be this section here of the graph. So that is what inequalities look like plotted out. And this is a common question that you would get. You get three inequalities, you're asked to plot their position, their lines on the graph, and then shade in a region that is dictated by all three of those inequalities. And remember, if it is a less than or greater than without the equals, you want to use a dotted line. And if you have less than or equals or greater than or equals, then you can use a solid line. So the last thing we need to be aware of when solving inequalities is if we have negative numbers involved. So say I have 10x minus x is less than 6. Well, the first thing that I would do, solving it like an equation, is probably get rid of this 10 on this left-hand side. So I'll take 10 away from both sides. So that is minus x is less than minus 4. And then I'll probably divide by minus 1 to get rid of the minus sign and just have x by itself. So you minus 1 there. So you'd probably think that that looks something like this. If I divide by minus 1 on both sides, x is less than 4. Well, let's test this out. So let's pick a number for x. Let's say x is equal to 8 in my hypothetical scenario. So let's test that initially. 10 minus 8 is less than 6. Is that right? Yeah, obviously it is. 10 minus 8 is 2, and 2 is less than 6. So it's true for my initial inequality, but what about at the end here? X is less than 4, and so x is 8. Well, no, it's not true. If x is 8, then that's definitely greater than 4. It's not less than. So this isn't right. The reason is, if we divide by a negative number, or we multiply by a negative number, the inequality sign flips round. So instead of having x is less than 4, it would in fact be x is greater than 4. So I've divided by minus 1 from this step here. I've remembered to flip the inequality sign around this time, and so this is the correct answer. So let me show you another example of that. So here, let me take 7 away from both sides. So that's minus 3x is greater than 6. And then let's divide by minus 3. So this would be minus 2 on this side, except I have not flipped the sign around because I want to check this with another number. So let's see. This x here would have to be a negative number to be bigger. So let's pick x is equal to minus 3. So minus 3 times minus 3 is plus 9. 9 plus 9 is 16. And that is greater than 13. That's fine. But now let's see. Minus 3 here is greater than minus 2. That's not right. Obviously, minus 3 is less than minus 2. It's more negative. So I've got to remember to flip the signs around. And now I have the correct answer. Dividing through by minus 3 here, flipping the signs around, x is less than minus 2. Yes, that's right, using my number that I'm using to check. So if you do happen to forget that you have to flip the sign around, flip the inequality sign around when dividing or multiplying by a negative number, a simple way is just to pick a number so that the inequality holds true at the start, and then place that same number in at the end just to double check you've got it right.